welcome to SIF 101. This tutorial has been produced as an introduction to SIF and the SIF Association and to help you understand the basic principles and capabilities. By the end of this presentation, we aim to introduce you to SIF terms, help you understand the definition of typical SIF components, understand the basic SIF concepts, understand how to utilize the SIF specification, and also be able to resolve basic issues by troubleshooting. Just as true in all aspects of education, SIF has its own nomenclature and language that we will be touching on during this tutorial. Here are some of the terms we will be tackling. SIF stands for the Schools Interoperability Framework. The SIF Association is a unique non-profit collaboration composed of over 3,200 schools, districts, local authorities, states, US and international ministries of education, software vendors and consultants, who collectively work to define the rules and regulations for educational software data interoperability, also known as the SIF Implementation Specification. The SIF Association is a membership organisation that serves the community of interested parties and helps to aid in the connection of these organisations. The SIF Implementation Specification is another part of what SIF is. The specification is broken down into two parts: a data model, made up of objects and elements, and an infrastructure. Both will be discussed thoroughly throughout this presentation. This collaboration has provided a specification that all interested organisations can use easily. So what problem is solved by using SIF? Before SIF, many school districts would register a child and then take the paper registration and enter the information by hand into several other databases, thus causing data integrity problems as well as many person-hours wasted. SIF minimises connection management risks between applications using a secure method of data transfer via HTTPS and also encrypting its messages. Without SIF, applications that label and store information differently cannot communicate. Human intervention and data manipulation has to take place for the data to flow from one application to another. So how does the SIF specification help with the communication within an organisation as well as communication to a governing organisation? SIF allows for the interoperability between applications without the need for all the unnecessary steps that happened before. All data is sent seamlessly and securely to its destination. At the core of SIF is the specification itself. Let's now examine the history of it and how it has grown. The first major SIF Implementation Specification release, version 1.1, contained 23 data objects, primarily relating to the core of what student information systems do. The next release, version 1.5 R1, built on the existing specification and expanded into the area of human resources and learning standards. The SIF Implementation Specification 2.0 R1 significantly increased SIF functionality with 118 objects and over 2,500 elements. The SIF Implementation Specification 2.4 went even further, including 158 objects and over 3,300 elements. And most recently, the SIF Implementation Specification 2.5 introduced important extensions to the model in the area of teaching and learning functionality, including extending assessment to incorporate the individual measures associated with a particular assessment item, providing a more flexible way to include established as well as new types of measures, by providing more robust structure for assessment psychometric measures that allow for a wide range of both innovative measurements and different test designs, and generalizing student participation to encompass multiple programs. Although the SIF Implementation Specification 2.5 did not add as many objects or elements as previous versions, it radically changed the landscape of SIF by allowing for the transport, data model and infrastructure to be split from each other. In addition, web services were also introduced. If you'd like to learn more about this, please refer to our SIF 2.5 tutorial located on the SIF website. Now let's turn our attention and dive deeper into the data model itself. SIF is made up of objects and elements. Objects contain several elements. Objects and elements have attributes that help define what kind of information can be shared in each one. To use a specific example, let's look at the student school enrollment object. The object attribute is the school year that one wants to look at. One element that is contained inside this object is the entry type, and this element's attributes are defined by a code list known as state or province. These attributes help the vendors who are creating the agents as well as the organizations that are using the agents. The SIF infrastructure is made up of several components. These are the zone integration server, the agents from each vendor organization, the applications that the agents interface with, and the protocol that is being used, whether it be HTTPS or SOAP. Most organizations have many applications that help to run the organization, but how do they communicate so there is no double data entry and good data integrity? A zone integration server, or ZIS. This is the traffic cop of the SIF implementation. It helps to guide the messages from the publisher to the subscriber. And SIF agents. The SIF agent provides the translator mechanism from applications it interfaces with. It translates their proprietary fields into the common language, which is the SIF specification. Using the SIF specification, data can travel seamlessly between applications via the ZIS using the SIF agents to translate the messages. In this diagram, we look at what is known as a horizontal integration, where the organization is tying together its own applications. This is a vertical and horizontal integration, the vertical being the data being sent to the SEA or other governing organization. This is done to facilitate with state reporting, as well as keeping track of students by using Universal Identifier. This example shows two ZIS that help to aid in the delivery of a unique identifier back to an LEA. The one for the SEA is interfacing with their unique identifier application, while the ZIS for the LEA is pushing necessary information to the state so they might receive a unique identifier. All previous SIF releases used HTTPS as the sole transport layer in the SIF infrastructure, but there has been increasing demand from the educational community to allow an application written as a standard web service to operate within the SIF zone. Introducing a second reference transport based upon SOAP, the Service-Orientated Architecture Transport, enables any web service conforming to the SIF Data Model to successfully exchange messages with any SIF application. For further information on the SIF Implementation Specification US 2.5 and the introduction of web services, please refer to the self-tutorial available from the website. SIF web services will interoperate seamlessly with previously deployed SIF applications, and they directly benefit from the entire set of SIF infrastructure functionality. Zones within a ZIS help with separating out different rules and agents that are in each zone, thus making it easier to manage. A governing organization, like an SEA, might need to interface with several LEAs that it oversees. If all the LEAs have a ZIS installed, then the data can come to the SEA's ZIS so that it may be compiled into one application. Due to the growth of SIF agents, many LEAs are starting to create different zones in their ZIS environment, each one representing a separate school or other sub-organization. In this example, you can see how this data is collected from several zones, even multiple zones inside the ZIS, to the ZIS, and eventually to the state. This diagram shows the hierarchy of how application data can all be combined and collected, for the ZIS then to distribute and push back out to all the necessary applications. A ZIS can be updated to the latest SIF specification. Some ZIS solutions can also translate previous releases, so the interoperability between, say, a 1.5 and a 2. Release can be negotiated. We will now review some of the essential vocabulary that is needed to fully understand how SIF messaging occurs. In a SIF register message, the agent communicates to the ZIS and identifies itself, indicating that it would like to take part in the zone, meaning either as a publisher or subscriber of information. In a SIF provide message, the agent identifies which objects it would like to provide or publish into the zone. An example will be the SIS providing student personal. In a SIF subscribe message, the agent identifies which objects it would like to subscribe to from the zone. An example would be the library subscribing to student personal. Note there can only be one provider, but many subscribers. In a SIF event message, the agent publishes an add, change, or delete event into the zone. Examples of this would include adding a new student, Michael J. Smith, change a student's middle name from J to John, or deleting Michael John Smith's address. In a SIF request message, the agent issues a request into the zone for specific information. An example of this would be requesting student personal information from the SIS. This is usually only done during a New Year rollover, if there's a new subscribing agent, or if there's a drop in communication between the subscribing and publishing agents. In a SIF response message, the agent issues a response into the zone as a result of a SIF request message. An example would be the SIS providing student personal to library application. In a SIF ACK message, one party is indicating reception of a previously sent message. Push refers to the action by a SIS to actively deliver messages to an agent without the agent having to initiate contact with the SIS. When the SIS receives a message for an agent and the agent is not in sleep mode, the SIS will initiate contact with the agent and send the message. Pull refers to the action by an agent to explicitly request a single message via the SIS. When an agent is ready to receive a message, it sends a pull request to the SIS to obtain a message that the SIS has saved in the queue. This is one example of what a message would look like that came from an agent. It shows the object that it is publishing, student school enrollment, as well as the elements within this object that the publisher is providing. To recap, here is the list of the terms that we have just explained. Now let's go over some basic troubleshooting that will help you with your implementation. With each scenario, we will propose a few possible solutions, but there may be many more. The scenario: the district has installed a new library application and has sent a SIF request to the SIS for student data, but no data has populated the library application. Now some possible solutions. This could be due to 1. A SIS that is down, 2. A version difference between the SIS and the library system and translation is not turned on, or 3. Either agent is turned off. The scenario: the SIS has sent an updated local ID for Johnny, but the cafeteria application still has the old one. Possible solutions include 1. Again, this could be a versioning difference. 2. The agents may be using the idea of matching, so a change of an ID may have to be done manually. 3. The agents may be down. Or 4. The agents may not be configured correctly. The scenario: a new student has been entered into the SIS, but a state ID has not been assigned. Here are some possible solutions. 1. Not enough of the demographic data was entered into the SIS to generate an ID. 2. There could be problems with the agent configuration or versioning. Or 3. Hardware failure. The issue of not enough demographic data being entered into the SIS is a very common problem. It is not a problem with SIF directly and can be easily fixed. The scenario: the state UID system has assigned student IDs for a very tech-savvy and secure district, but no IDs have populated the SIS. Here are some possible solutions. 1. There could be a firewall issue. Or 2. There may be a possible acceptance process that may have to be run through. Here is the last troubleshooting scenario. Two applications are not in sync. Both vendor support teams have indicated that their application is working properly, and it is the other application that is in error. Here are some possible solutions. 1. This could be a mapping issue. 2. It could be a versioning problem. Or 3. They also may be looking at very different years of data. So have we met the objectives? Have you learned something new about SIF? We hope that the answer to both questions is a resounding yes. Here are a few links to additional information that you may find useful. Please contact us if you have any further questions. We thank you for your time and interest.